Alrighty, so now I'm going to write some Pythagorean theorem identities. Okay, so and of course you could always derive these, but for this video we're just going to write them. Oh, that's it. Those are the new ones. Okay, and so for example 7, it says use fundamental identities. So it says given cosine theta equals -3/5. In quadrant 2, find sine of theta and tangent theta. Okay, so there's two ways to do this. So the way that I would probably do it is use this information here because they want us to find sine. And we already have cosine, so we use the first formula. It says that sine of theta plus cosine squared, right? So cosine is -3/5. Cosine theta squared equals 1. And so we just do the math, solve for theta, right? So here, what's -3/5 squared? Or in other words, what is -3/5 over another -3/5? That'd be 9/25. So this is 9/25. Solve for sine theta, which means I need to take away that 9/25. Okay, instead of 1, I'm going to rewrite it as 25/25, so I could have the same denominator. And when we do this, what's 25 minus 9? 16/25. Okay, so then we get that sine theta squared equals 16/25. And then of course, square root both sides, and you'll be given sine of theta, which is 4/5. Remember that since both of these numbers are in the square root, you can solve them individually. What's the square root of 16? 4. And on the denominator, what's the square root of 25? 5. So we get that the sine of theta is 4/5. Well, technically, because the square root, it's plus or minus. But if you look at the second quadrant, where this is from, right? What would be the sign in the second quadrant, or what's the y value in the second quadrant? It would be positive. Okay, so it's just positive 4/5. Okay, awesome. And then now that we have sine and cosine, we can just get tangent. Remember that tangent is sine divided by cosine. So that would be 4/5 divided by -3/5. Okay, here, because we're dividing two fractions, we'll keep the first fraction, change long division to multiplication, and flip the second fraction. The 5's cancel, and we're left with -4/3, and you can leave it like that. You don't have to turn it into decimal or mixed number. Okay? So we have successfully done it. The other method is to draw a triangle, find the reference angle, which we've done a lot, use Pythagorean theorem, and you would get the same answer. So for this example, we're just going to use the identities. Okay, and the identities are not hard to get to. So let me show you. So going back to x squared plus y squared equals 1, which remember that when we get the radius of a unit circle, it's 1. Right, so x squared plus y squared equals r squared, where r is 1. And so here, this is the formula we get. Now, remember that x is cosine theta, sine y is sine theta. So that is how we have the first identity. Okay. Alright, if we were to divide everything by cosine theta squared, you would get 1 here. Here you would get sine divided by cosine, which is tangent squared. And here, what is 1 divided by cosine? And then of course squared, because the cosine was squared. Okay, so that's the other identity. Right, so all you need to know is this formula, and you can get the 3 identities from it. And then, last but not least, let's say you didn't want to divide by cosine theta. You prefer to divide everything by sine theta squared. Then here, what is cosine divided by sine? The opposite of tangent, which is cotangent theta. Here, sine theta squared divided by itself is 1. And here, what is 1 divided by sine? Cosecant. And then, of course, it's squared because the sine is squared. Okay, so those are your 3 trig identities going all the way back to x squared plus y squared equals 1. The radius of a unit circle is 1. Okay, so that concludes 5.3. 5.4 will be using the unit circle to define trig functions. Alright, so we'll be able to just use the unit circle every single time instead of having to use the referencing. So make sure that you review these videos, do your homework, and check out 5.4.